Good afternoon. My name is Himanshu, and I will be presenting my assignment 3 of Big Data Technologies. So I started my assignment with installing necessary libraries, and then I imported all the necessary libraries as well. And I then loaded all the three files, and then I stored them in all three different data frames, df1, df2, and df3. I displayed their content. And for task 2, I combined all of the three data frames into one. And then I went out with three trends. First one is hourly pickup trend, which showed me the lowest and highest pickup on the hour of the day. And demand was lowest during the 4 and 5 a.m., while it was the highest at 6 p.m. And then second, I went with the rate code trends, which showed which rate code was most preferable by the customers. And for the third trend, I counted passenger count trends. So how many passengers travel? Those for most was a singular passenger, followed by a pair, and then 3, 4, and 5, and it goes lowest as we proceed. For task 2, data exploration pre-processing, I noticed that we had 5 columns, which contains 71,743 of missing values. So I imputed them with mean and mode. So for numerical values, I imputed them with mean, and for new categorical variables, I imputed them with mode. The reason I used mean for numerical columns was to maintain the central tendency of data, and for categorical variables, because it usually had yes or no, y or n. So whichever was most used, I used it. And so I can see that there is no missing values now. And then for task 2, I displayed the summary of TF1, which showed necessary findings I could find. So there were multiple columns with noisy data. The two I was able to identify at first was the passenger count with 0 passenger count in the trip. I mean, that's all. And for fair amount to be negative, oh nah, it's not it's unusual. I mean, fair amount cannot be negative, right? For other columns like passenger count, fair amount, and all these columns, they did have noisy data as well, mostly of negative amounts and with 0 passengers and all. So the next task, we were supposed to tell the correlation. So I displayed the correlation heat map for DF1 for all the numerical values. And I was able to find that the highest correlation was at the total amount and fair amount. So, which means this was the highly correlated, which means that the total amount is mostly the fair amount. Total amounts includes the pips, the tolls, and all. So all the other things merely contributed to like much less. So the fair amount was the most majorly contributed in total amount. And for the next task, featureization, I created a feature which tells us if a trip is in the rush hour or not. So for rush hour, I define the time for morning and for evening as well. Between 7 to 9 it is morning, and between 6 to 9 it is in the evening. Yeah. No, actually it's between 4 to 7. Yeah. So I converted the daytime columns to daytime objects, and then I created a flag. So if rush hour, and I added in the DF1. So if a trip lies, the daytime lies between these times, the morning rush hour and at end times, and evening rush hour at end times, it will be flagged as a rush hour. So there are a total of 26.91% of rush hour trips. And in here, I let a user enter the trip index, and it will let you know if your trip is during the rush hour or not. For the next task, I loaded the shapefile taxizones.shp. I displayed its contents, and then I encountered it. Some of them were polygon and some of them were multi-polygon. So I iterated through all the rows in the data frame, and from for each zone and the geometry. So it displayed all the zones which associate with their coordinates. Yeah. And then I created a data frame to map the location IDs to zone maps. So for each pickup and drop-off zone, and which their location IDs. So there was 330 lakh 67,972 of total trips. Then I transform the text zones from its current CRS to WGS84. This is the most preferable. By using this statement, I was able to find this on the Google. Yeah. And then I created a spatial index to fasten up the process. It was taking a lot of time, large data set, I guess. And then I created a dictionary, location ID to centroid, which maps the location ID to geometry. Then I created a function, calculate straight line distance, and with the PU pickup location ID stored equal to PU location ID, and same for drop off location. So if I pick up location ID is in location ID to centroid, and the drop off location ID as well, and it will store in pickup centroid and drop off centroid the distance from the pickup location to drop off location. So the straight line distance will be the pickup distance between the pickup centroid and the drop off centroid, and it will be stored in the straight line distance. And then I added this column to df1 and displayed it along with the trip distance and pickup and drop off zone. See. Next, I calculated complexity by dividing trip distance with straight line distance. I defined a for loop here for trip distance and straight line distance. And if the complexity is 1, like when the total distance is equal to straight line distance, so it will be complexity equal to 1. Then I added it into a df1 and displayed it along with other columns as well. For the next task, I calculated the frequency of pickups and drop-offs for each zone. I calculated total pickups and drop-offs and then calculated their percentages of the total percent for each pickup. So for each zone. So each zone represents how much percentage of pickups they had in total pickups and drop-offs as well. For the last task, the data analysis. For the first task, I calculated each the number of trips for each vendor, and I found out that the vendor with vendor ID 2 was more popular. For the next task, I categorized the day and each pickups associated with them and drop-offs as well. So Tuesday was the highest with pickups and drop-offs, followed by Thursday and Saturday. So then I converted these columns, TPAP pickup date time to daytime data time, and calculated the frequency of pickups for each hour. And I displayed it in form of bar chart. We can see that for the hour 18, it is the highest. Is the peak travel hour, yeah. So 17 and 18, between 5 to 6 p.m., people will be leaving for work, I guess. That's why it's the peak hour. For the next task, I converted into data. I guess I already did that, yeah. So I defined a function to map the day and of the week into weekday and weekend. So if a day lies between 0 to 4, Monday to Friday, so 0 counts for Monday, then Tuesday, Friday, Thursday, and so on till 6. So Monday to Friday is 0 to 4, a weekday, and 5 and 6 are weekend. I applied this day mapping to create a new column day type, and then I grouped the day type to calculate the average trip distance along with each day. So for on weekdays, the average distance was 3.74, and for on weekends it was 4.11. That is significant because 5 days is the average distance is 3.74, and for on weekends people tend to move out on weekends. The average distance was 4.11 miles. For the next task, I calculated the passenger count, average passenger count on weekday and weekends. On weekdays it is this much, and on weekends it's 1.446046. For the next task, I calculated the correlation between fare amount and tip amount, which is 0.589. This is a positive correlation, which means that if the fare amount increases, the tip amount will also increase. So higher fare amounts, higher tip amount. Then I calculate correlation between fare amount and number of passengers, and it is almost near 0. So these two are not associated with each other. Like if the fare amount increases, if the number of passengers increases, the fare amount tends to remain the same. It doesn't affect much. Task 5. I have included all my findings, the trends, the missing data, noisy data, the peak hour, all of them are findings. And these are the issues that I faced: missing data, these errors that I encountered, these technical errors. With the point function, it used only scalar, and we have got empty data frames as well. So I prevented it into entering through reading it as an empty data frame. I was able to solve this problem. For merging with mixed data types, like location IDs, in one it was int type, and in the other was it was float. So I have to match them for same data type to map them. Visualization choice, yeah, for each pickup zone, pickups and all. I used a heat map and a dendrogram. It was so messy, so I just went out with the tabular format. And I also encountered this error, which was because this limited my data exploration. I just solved it by increasing the data rate limit. And for last task, we can we have multiple options to do further analysis. We can do rate analysis, route analysis. We can do like how the trips are affected by seasons during a year, how the couples of married or unmarried people take the trips. So there are multiple options. And here I will be providing a YouTube link to my this video, and that will be all. Thank you.